Okay, so this one is chapter 16, and we'll get into sheet metal forming processes and equipment. So in this keynote, what you need to know is the sheet metal forming processes, right? They are versatile, of course, um, most versatile of all metalworking operations, right? And they're used on workpiece with high ratios and this ratio is your surface area to thickness. Pay attention, we have different ratios for different operations, okay? So in sheet metal forming, your ratio is your surface area to thickness, right? And we're dealing with very high ratios of this, okay? Sheet metal forming operations, they prevent, right, sheet thickness from being reduced, right? So this forming operation is unlike, alright, extrusion and drawing because it prevents, alright, the sheet thickness. So here, right, I write it here for you, yeah, forging, extrusion, right, because they are a bulk deformation process. So try to remember sheet metal forming, we prevent the thickness of the sheet. Important material parameters: the quality of the shear edge of the blank, the capability of the sheet to stretch uniformly, and the material's resistance, alright, to thinning. And the next one is your normal, planar, and isotrophy. And then you have your grain size, and then you have your yield point elongation. And this one is for low carbon steel material. So these parameters are important in sheet metal forming process. Right? You have to pay attention to them. Forces and energy that we need to do this process, sheet metal forming, right? We're going to transmit them to the sheet through the solid tools and dies. By what? So by flexible rubber, right, or polyurethane members, or by electrical or chemical, magnetic, and gaseous means, right? So by using these means, we're going to transmit the forces and energy required, right, in this forming process to the sheet. Of course, you're dealing with a metal sheet. Okay, so we're going to pay attention to significant factors and, of course, the significant factors in sheet metal forming process, because we're dealing with relatively thin material in this process. So we pay attention to spring back, your buckling and winkling. Spring back, buckling, and wrinkling can be reduced or eliminated. We can use proper tool, we can use proper die design to do that. You can also minimize the unsupported length of the sheet during processing. So by doing that, you can be able to reduce them. You can control the thickness, right, and surface finish of your incoming sheet and its mechanical properties, right? So by controlling them, we can be able to reduce or eliminate spring back, buckling, and wrinkling. Okay. Another important process for making complex sheet metal structure is your superplastic forming, yeah, of diffusion bonded sheet. Especially for aerospace application, we use it. So aerospace application is like you're dealing with a high, okay, stiffness to weight ratios in this application. That's the reason why we're using a superplastic forming, right, of diffusion bonded sheet, because we can be able to make complex, right, sheet metal structures. Of course, in aerospace, we use the complex structures. test methods. We use several test methods. What are we testing here? Since we're dealing with forming, we're testing for formability of your sheet metals. Okay, so in stamping operation, if we generally look at this operation, we use a forming limit diagram, right? Because we can be able to get the quantitative relationships out of these diagrams. Okay, the kind of relationships, right, can we be able to get from these diagrams? We can get the major, minor, principal strains, all right, that limit the safe forming, and this is very important information, very important relationships, right? Because by knowing, right, their strain limit, we can be able to control the forming process. Yeah. Okay. I'm gonna go ahead and stop here for chapter 16, sheet metal forming process and equipment.